The sun is a great thing to have. It's responsible for not only keeping Earth warm enough to sustain life in the first place, but the light it produces is crucial for the survival of pretty much all plants and most fungi, which keeps the food chain afloat. But what if I told you that the same thing that makes Earth come alive to begin with could, in theory, also be responsible for something that could shut down the power grid for weeks or even months on end at a global scale? This is what we call a solar flare. Now, before I get into these agents of chaos and destruction, I'd appreciate you to like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so before we can understand how these solar flares can cause such massive devastation on Earth, we need to understand what a solar flare is. To put it bluntly, they are absolutely enormous ejections of plasma, which make up pretty much the entirety of the sun as a whole, combined with a significant electrical charge from the sun's magnetic field itself. The reason why these ejections happen is that, unlike the Earth's magnetic field, which is relatively smooth, the sun's magnetic field has numerous twists, turns, and loops that result from the magnetic field rotating at a different speed from the sun itself. Sometimes, the magnetic field will get caught in a knot, which will then accumulate energy. Oftentimes, the knot will produce what is known as a sunspot, which is a spot on the sun's surface with much higher magnetic energy and a lower surface temperature than the rest of the sun. Eventually, the magnetic field violently straightens itself out, in the process releasing all of the pent up energy that was in the knot. This process releases billions of tons of plasma and extremely high amounts of magnetic energy from the sun, which careens into space at thousands of miles per hour. In some cases, a solar flare will take less than 24 hours to reach Earth's distance from the sun, but usually it will take on the order of a few days. In addition, the size and strength of solar flares varies drastically, with three major groups categorizing their intensity: C, M, and X, which is determined by the size of the knot and how much stored energy was released when it finally straightened out. One more thing to mention is that solar flares are not produced in equal quantities at all times. Instead, it operates on an 11-year cycle, with about a year period of heightened solar activity usually being interspersed with 5-year periods of lower activity and fewer sunspots overall. Again, however, the peaks and valleys of these cycles aren't uniform as well, with some active phases producing fewer sunspots and some inactive phases producing more sunspots. Okay, so now that we know what a solar flare is, what happens when one hits Earth? Well, solar flares happen all the time, and they hit Earth all the time, and yet clearly we don't get power outages every single week. Well, as it turns out, Earth has its own magnetic field protecting us from deadly solar and cosmic radiation. When a solar flare hits Earth's magnetic field, what will usually happen is that the electromagnetic radiation associated with it gets absorbed by the magnetic field and is then diverted towards the poles. Once there, the charged plasma ions will react with particles in the upper atmosphere, which causes the brilliant displays of auroras that are so well known to the Arctic and Antarctic. Aside from causing pretty displays, smaller solar flares will almost certainly not have much effect on the surface, with the only things that might happen being isolated radio blackouts and temporarily disrupted communication with higher orbiting satellites. With very large solar flares, however, things change rapidly. This is because they can easily overwhelm the defenses our magnetic field tries to put up. And as a result, strong electrical currents can easily reach the surface. This, in turn, caused a massive influx of power to the electrical grid, a surge that almost every single power grid on the planet is ill equipped to handle. The end result could be global blackouts that could take months or even years to repair, and trillions of dollars of damages in total. Such a thing would also severely damage certain satellites as well, which could lead to spotty or even non existent internet on a large scale, which, in a world that pretty much relies on it, could be catastrophic. Some of the more dire predictions have humanity essentially falling back to the Stone Age as a result of such an event, but chances are that won't actually happen since the power grids could eventually be repaired. It would just take a while. So you might be wondering, how often does such a cataclysmic event happen? Well, the last time something like this happened was the Carrington event of 1859, which is the most powerful solar flare in recorded history. At this point, electrical software was far more rudimentary, as humanity only really had the telegraph and not much else. However, even these failed pretty much worldwide, in some cases even shocking the operators. In addition, such strong storms can produce remarkably strong and far reaching auroras, which in this case reached as far south as Cuba and Hawaii, and they were so bright in much of the US it allowed people to read at night. Since then, no major storm has hit Earth, but there was an exceptionally close call in 2012 when a solar flare of similar magnitude was fired towards Earth's orbit when Earth was on the other side of the Sun. Since the Sun rotates every 27 days or so, had that solar flare gone off 2 weeks earlier or later, the world might look very different now than it actually is. Talk about the world almost ending in 2012. Less severe events have managed to hit Earth, with one of the most notable heading in March of 1989. This storm was strong enough to completely shut down Quebec's power grid for a full 9 hours and cause the auroras to show as far south as southern states like Texas and Florida. Overall, NASA estimates that there's approximately a 12% chance of a solar flare with a magnitude similar to that of the Carrington event for every 10 years, which adds up to roughly 50-50 odds over the next half a century. Given that the risk is that high, power companies and the government have made some investment into making sure the power grid can handle the surge of excess energy caused by such an event. The goal of these investments is to reduce the scale of potential power outages as well as the overall damage to the grid so it can be repaired faster and cost less money than it would otherwise. So again, a complete meltdown of society seems unlikely even if such an event does happen, but it might be a good idea to have something to do if the internet goes down, just in case. And that's all I have to say about solar flares. As always, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.